My name is Joost Tornend and I'm the marketeer at Chess. At Chess we develop MyMesh, which is a system that allows you to turn any professional location smart. Today I'm going to tell you more about smart buildings, how to create them, and where you need to have your focus on. Like, where do you start? What are your bottlenecks? I built this presentation for like beginners who want to know more about smart buildings, but also for experts who already know a lot. I think you can learn something from this presentation as well. I'm going to try to be quick, so it's probably 30 minutes or so. And if you have any questions, comment below, and of course we will answer your questions. So let me begin. First of all, what is smart? Is smart the buzzword, or is it a technical revolution? What do you think? Personally, I believe it is the technical revolution everyone is talking about. And I will explain you why in this presentation, or at least I will explain you why right now. So let me translate it to something we all know. Most of the viewers, they still remember that Nokia phone you see on the left. It's the model from 1998, and it could call and it could text, and Nokia was fantastic because it had a very user-friendly interface. And then in 2007, Steve Jobs appeared on the stage with this brand new phone, the first smartphone. But what made the iPhone smart in contrary to the Nokia? Well, it was because of apps, or at least it was because the role software plays within the life cycle and usability of the product. Let me explain that. Software updates, they further develop a platform. Let's say that iPhone. Apple constantly updates their iPhone in order to increase functionality and in order to increase the possibilities on that platform. And then on that platform itself, third-party developers can create applications or apps which add features to your platform or to your phone. And then there are upgrades. So software enables producers to differentiate their products. A good example is Volvo. Volvo builds a lot of engines, different engines, but some are identical in terms of how the engine is constructed. The only difference between those engines is the software or the firmware that runs on that engine. So where one engine is very powerful, the other one isn't, and it's just software. So it's a way for producers to differentiate their products. And software becomes more and more important in the world we live in right now. So let's go back to, let's say, 10 years ago. What do we see? Well, 10 years ago, just before 2010, actually it was 2007, we saw the big change from conventional technology to smart technology. Conventional technology is technology that leaves the factory with a fixed purpose. So you had your phone to call and to text, and you had your VHS videotape to watch movies or to record like your television. And then you had your car just to transport stuff. But all these products, they came out of the factory with one single purpose. There were no software updates. You just use them till they're done. And if you look at the rate how technology is advancing, which is Moore's law, then you can see that there is a big shift going on here. So Moore's law, Gordon Moore, he was the founder of Intel, and he predicted in 1965, around 1965, he predicted that the amount of transistors on a processor would double every 24 months. So transistors on a processor determine the processing speed of that processor. So every 24 months, the processing speed of a processor would increase, which is amazing. So From 1965 till 2007, where were we? Right there. Like I said before, 2007, the year that Steve Jobs jumped on stage and he presented the new iPhone. We had just below 2 billion transistors on our processor. Now, 13 years later, we have more transistors on our processor, and that's an understatement. So let's see where we are right now. This is what happened in the last 13 years. 40 billion transistors on a processor. That's where we're currently at. Or while I made this presentation, that's where we were. But as you know by now or understand by now, it's much more. And because of this technological advancement, we need products that can adapt to those new possibilities, but also to the needs of the user and to the influences of the outside world. So we came up with adaptive technology that changes with the environment, with the user, via software updates or via software. So we got the iPhone, which I just explained. You got Netflix. You do not own movies on Netflix. You simply pay them to watch their content, and they will determine, or they will analyze what you like, and they will serve you the products or the movies or the content that you want, which is software as a service basically. They maintain their platform, and you just pay for the use of their software. And then there is of course Tesla. And Tesla is amazing because a Tesla car is a computer on wheels. In this case, guys or people who bought the first Model S, it didn't have any of those fancy features it has right now. But I imagine a guy sitting on a sofa and getting a notification from the Tesla app on his phone. Hey, there's a new update. Do you want to update? Yeah, sure. You pressed yes, you went to bed. His car updated all automatically. And then, somewhat later in the morning, his car could drive all by itself, which is amazing. Another good example of Tesla is that during the California bushfires, they uploaded software that enabled Tesla owners to drive 60 miles more just to get to safety. That's what software can do with products nowadays, and that's where we are heading. So what played a major role in this transition? There's definitely something going on, but what? Well, we are right now in Industry 4.0, the fourth industrial revolution. So what does that mean, and how does that work? Well, in our lifetime, we had, well, as you can see, 4 industrial revolutions. And it all started when our muscle was replaced for machines, which we were able to do with steam. In this case, steam was a driver for change during that era. And steam gave us more power, it gave us more output. And then, 100 years later, we came up with electricity. Electricity was a major step forward because those big clunky steam engines were now replaced by big clunky electromotors. But also electricity, it caused a shift in how we work. Is where factories couldn't work night shifts. They didn't even have shifts. And now they could. Now they had enough lighting to keep their shifts going. So people from the rural areas, they came to the cities in order to work at factories where they worked at conveyor belts. So mass production, assembly lines, and it all had to do with electricity. Again, 100 years later, automation, computers, microchips, especially electronics, it really became a thing. And as you can see, 1969, it's around the year that Gordon Moore founded Intel. Um, and now we are at a difference. Now we again are at a very important stage, and that's the Industry 4.0, which is the Internet of Things and data infrastructure era. So let me dive into that. What does that mean? What is Internet of Things? Internet of Things is attaching a device that can track objects, devices, people, animals, basically anything in the world that can be tracked via a unique identifier. And then because it has a unique identifier, you can withdraw information from that object, machine, animal. Um, let's talk about cows, for example. If every cow has a necklace that gives you its heartbeat, that gives you his position in the meadow, etc., etc., you could observe the behavior of your cow. You could see whether or not it is sick, or it is not doing well, or it is doing very well. You could connect it to the milk output, for example. That's already IoT. But if we transform that philosophy to a smart building, we see that we have sensors in on every floor, in every room. We have sensors everywhere. And what we can do is we can take the information from those sensors and we can use it to control our actuators. So what are actuators? Well, actuators are devices that create differences within the environment. So an actuator can be a light, for example, or a valve that, or a ventilator, or something like that. It's a machine that, or device that turns on and it changes something in the environment. And this is if you sensor actuator, this is nothing new. This is nothing new. And in the middle, we have something that is very, very important, which is a way to transport our data from A to B. This is nothing new. What is new is the amount of devices that we're connecting. So just like Moore's Law, the amount of devices that we are connecting every day is increasing. So in 2012, we had 8.7 billion connected devices, whereas we now have 50 billion, more than 50 billion connected devices in 2020. And as you can see, the rate what this grows is where are we next year or that year after? It's going exponential, and more devices need to be connected. So you need a good infrastructure. You need a digital infrastructure. In your building, when you're connecting so many devices, you need a digital infrastructure that is able to do so. So what is a digital infrastructure? Well, digital infrastructure, kind of compare it to a highway. You got a highway and you want from A to B, just like your information. Remember the sensor and the actuator? You want to get from A to B, but you want to get there quickly, right? You want to drive 130 on the highway and not 30. You want to go there in the safest possible way. You don't want to see any potholes or obstructions, or you want to go from A to B as fast as possible with 100% certainty that you will arrive there. And then it needs to be interlinked. Like the highway needs to take you anywhere. Every city needs to be connected to that highway. And the same goes for every device. Every device in your building needs to be connected to that highway or to your network. So let's dive in. If you have two, because this is where it's all about. This is about the infrastructure. What kind of infrastructure are you going to build, and what is the difference between infrastructures? So if you have two devices, which is very easy, it's a very simple connection. Two devices, you connect them either via Bluetooth or via an Ethernet cable. And there's no hierarchy here. Both machines are the same. They both function the same. There's no hierarchy. There's no management between this connection. So what if we want to connect 10 devices the same way, we get 10 devices, 45 active connections, and 9 plugs per, in this case, computers. This is called a full mesh network. There's no hierarchy here. It's super reliable because if one device breaks down, all the other devices will keep operating. But it also means that if you look at this, it is nearly impossible to achieve because you simply can't connect all those devices. So what did we do? We came up with a term called star networks. The star network is a network where, in this case, a router is at the middle of that network, and the router handles with all the information, all the data, just like a traffic operator waving you through a cross section. This router is waving all your information from one device to the other. But there is a bottleneck here. As you can see, there's a hierarchy. It means that the router is higher in hierarchy than the devices it connects. So if you take away the router, eventually all the devices stop working. Compare it to your internet connection back at home. You are connected to a router, and if you unplug the router, all the devices in your home, they will lose internet because they can't connect to the network because there is no network. The router is the network, and there's a hierarchy. The other problem is that the router can't handle like a lot of devices simultaneously. It can do 10, it can 20, but the more devices you connect, the slower your connection is. You probably know that from first experience when you're using internet on an airport or in a restaurant or a place where a lot of people are. Then the internet is mostly slow because so many people are using it and so many devices are connected. So what they came up with is to connect router to router. So you have two sub networks and you connect them via routers, which is fantastic because you can now scale. And you can scale and you can scale and you can scale and you can do this every time. What you see here is you see a network where routers connect to routers and routers connect to routers. And what you can also see is that there is a huge hierarchy already. Like you have the router that directly connects your devices, and then it connects to another router, which connects to different routers. And you don't want any of those devices or any of those routers to disconnect or to have an error, because then you will lose or your entire network or you will lose part of your network. It also means that because of interoperability, you probably need to connect it to the internet. So you have all these devices and you have devices from manufacturer A and devices from manufacturer B, and you need to connect them to each other, but how are you going to do it? And most of the time people connect them via the internet. Here we go. So we connect the network to the internet via a modem, and the modem connects to an internet service provider. Here in the middle you will see the internet. This is the internet basically. So you have your network, you have your router, then your network is connected to a modem, and your modem is connected to an internet service provider. An internet service provider has, well, let's say a special router that is able to connect other routers of other internet service providers, which if you do that globally, you will end up with the internet. This is how the internet works. And on the right side, you will see that's our modem and our internet, like our network, our building network. So we can either talk about lights, we can talk about switches, we can talk about any device in your network is connected to that network. But what if one of those devices has an exploit or is corrupt or is being vulnerable to cyber attacks? So what you get is that if you can get in via one of those devices, you're in. And once you're in that network, you can do a whole lot of bad stuff. It's like building a house, building or installing all these windows, and you can never be sure if that window is actually locked or not. You have Like the world has access to your network, and if you do not know if your window is open or not, um, you have no guarantee to be safe. And this is where safety comes in. So a big American supermarket, they wanted to adjust their air conditioning on the behavior and presence of their customers. So what did they do? They hooked up their own air conditioning to their network. And unfortunately, the air conditioning had a flaw. It had an open window, and cyber criminals were able to penetrate their network through the air conditioning and eventually ended up stealing like millions of credit card data, which was a very bad case for them because security, you would, as a customer, you would not feel safe paying with your credit card at a supermarket where that just happened. So that's how important security is and how easy it is for cyber criminals to penetrate your network through exploits in one of your devices. So, okay, where do we need to start? That's basically the question, isn't it? So start with what do you want to achieve, but also how many devices do you want to connect? How important is safety for your building? In what environment is your building located? This might sound strange, but it isn't. In the Netherlands, where I'm right now, internet is everywhere, and having internet is like a certainty. But abroad, internet is no certainty. Like maybe you don't have stable internet. So do you want to have a network that is able to operate without internet? Or do you always have to have stable internet? That's an important thing in choosing your infrastructure. Also, what bottlenecks do you encounter? Like, where are the bottlenecks in your network? Just start thinking from there. Like, what infrastructure do I need? Where do I start? Well, you start with an infrastructure. But what kind of infrastructure? That's for you to decide, and that's where a lot of these questions come along. So at Chess, we 20 years ago we came up with the 4 pillars for our network technology, and we said a network needs to be, in order to perform in a professional environment, the network needs to be scalable. That means that just like that router, it can scale from 10 to 100 to 1,000 to 10,000 devices without any issues. So 10,000, maybe even 100,000 devices in one network. So we built a network that was able to do so. Then we said it needs to be secure. If you want to work in professional environments, if you want to make the biggest and most demanding location smart, it needs to be secure. You don't want a smart hospital to be vulnerable to cyber attacks. You simply can't have that. So it needs to be secure, and it needs to be secure by design, which means that every operation, offline and online, needs to revolve around security primary. It also means that you sometimes have to give up certain functionalities in order to preserve your security. And then we go to adaptive. So I just talked about adaptive. It needs to adapt to the future. It needs to be able to update and to add new functionalities to a building. And then we, of course, have the building. Well, I don't know what happened, but that went automatically. So here we go. And the last one is, of course, robust. You want your building or your network or your infrastructure to be robust and reliable. So what do I mean with robust? I mean self-healing. See, if you have a cabled network and you cut the line to, for example, the router, then your entire network goes bust. It just drops out because that one cable is cut. Whereas if you have a wireless network, the network becomes self-healing because signals travel through the network, and signals can travel from device to device to device via 1,000 different ways. So you eventually end up with a very robust and reliable network where the chance of error is close to zero. So let's go to that next slide that the computer already showed you. This is a cross-section of a smart building. And So what devices do you see? You see lighting. You see your HVAC. You see blinds, toilets, elevators, fire safety, water management, waste disposal, all these types of things. And of course, there are a lot more systems in a smart building, but there are thousands and thousands of devices you need to connect in order to have a complete overview of what is happening in your building. All these sensors and actuators need to be connected, and you need that infrastructure that is able to do so. So how did we do it? How did we solve this problem of scalability, and how did we solve it? Well, let me explain to you how my mesh works, and then you can decide whether or not it is the solution to your demand. So what we did is we used the lighting infrastructure, or the lighting in a building, as an infrastructure to transmit our wireless network. Lighting is everywhere, and therefore our network is omnipresent as well. As you can see in this image, you see the blue dots. They represent like the spots that they represent our nodes. Nodes are network devices, and these network devices are everywhere in your building, creating a reliable and robust radio network. And then you have the pink dots, and they represent sensors, which are connected to the network as well. And if you create it like this, every device in your network is connected. But then again, it needs to be scalable, it needs to be secure. So under the flag, or what's the right idiom? Well, we use lighting control to get into a building and to create a network like that. So you have normal lighting control, and then you have MyMesh. And if you choose MyMesh, you will get the data infrastructure in order to do so. And the best thing about this infrastructure is it's a full mesh. I showed you this image, and I said that it was nearly impossible. But nearly impossible does not mean it's impossible. We solved this problem by taking away all the cables and making it wireless. And if you make it wireless, you don't need so many cables, you don't need so many plugs. You just need to create an entire new protocol. How the network communicates. So what Chess did, and they started 20 years ago, was they looked at nature. And in nature, like biomimicry, it's called, I guess. In nature, like flocks of birds or a school of fish, they communicate in a certain way, which is non-hierarchical. Because if you shoot down one bird, the rest will continue flying. It's the same with fish. The entire flock or the entire school, they respond to influences, and the lost fish can communicate to the first fish in the school, or vice versa. So it's a very interesting way of communicating. But how do they do it? What is happening there? So we did the research, and what we eventually found out was they communicate in a way where they send a signal, and then they forward that signal to their neighbors, and then the neighbors receive that signal, and they forward that signal to their neighbors as well, which is what makes it so fluid. In this GIF or how do you want to call it, in the top left you will see a network device that receives a signal, and then because it receives a signal, it forwards that signal to its neighbors or to its surrounding neighbors, who then forwarded it, and then forwarded it, and then forward. So what you get is a tidal wave, a very powerful tidal wave that flows through the entire network, and that makes sure that every device in your building, and let me be clear, these are thousands of devices, every device receives what is going on. So let's continue. So we now have the sensor. We have an infrastructure, which in our case is wireless. and we have an actuator. So now you have the option. Do you want the control of your network? So the sensor senses something, sends it to the network, and then what? What does the actuator need to do? Is there anything it needs to do in particular, or it just needs to be idle because it's not for him? Your network determines what it needs to do, or eventually you determine what it needs to do. But where lies that control? You can do it internal, or you can do it external. So what I mean with external is that your network is connected to the internet, and then your settings and configurations are there on the internet in the cloud, and then come back to the infrastructure to go to the actuator. The other option is to have an autonomous network, which knows how to operate even without internet. So it knows what to do, because let's call it the intellect, but it's not really intellect. But it knows what to do on a local stage. So this is how my mesh works. Everything is local. All the data in the network is decentralized, which means that if a hallway goes dark because there's no electricity and the hallway comes back up again, the rest of the network will tell those devices, hey, this and this happened, this is what you missed, and this is what we're going to do, these are the encryptions, etc., etc. We call that gossiping. Like, they constantly gossip, tell each other what's going on, where they are at, etc., etc. So there's a lot of data in that network. But what can you do with data? Well, you probably watched a good documentary on Netflix, The Social Dilemma. And if you didn't, well, go watch. But data is very important. All big tech companies are lurking for your data, and there's a reason why. It's because data is about power. Data is knowledge, and knowledge is power. Data is more valuable than oil is a common saying nowadays, but Clive Humby from Tesco, he was probably the first one to say it. And why did he say it? He said it because with all the focus groups to learn and to get to know his customers, he still didn't get to know them well enough. And then a magical guy appeared in his organization, said, okay, we're going to analyze like club card data to see what people are buying and why they are buying it and when, and et cetera, et cetera. And what happened was, within 1 month, they knew more about their customers than with 30 years of focus groups and researches, all because of that data. Why do you need data in your smart building? Do you even need it? Well, answer is yes. You need data because you need to become more efficient, but you also need to understand what is going on in your building. And how new products can maximize the output of your building. For example, if you know that with data analytics in your building, or with a certain algorithm, which is you can I'm just making this up as we go, but you can connect your CO2 sensors to an environment and to, let's say, a motion sensor. And because you have two data sets with a formula, you can calculate how many people there are in a room. You don't need a special sensor to tell you how many people there are. You don't need to do a head count. You have two data sets, and based on that data set and basic statistics, you can come a long way. That is why data is so important. But data isn't easy to get. It's everywhere, but where do you get it? And what do you need? Well, I spoke to multiple data experts. I'm not an expert, but these guys are. And I asked him the same question, like, do I need all data? And party A said, yeah, you need all data because you never know in the future what value is stored in that data. And the other party said, well, no, it's a waste of time, it's a waste of space, really, to save all data, and you just need to know what you need in order for you to build new products or in order to achieve your goals. So there's no consensus on that. I can't tell you what to do, but you have to make that up for yourself. What is important, though, is to know what your goals are and to explore the ways how you're going to withdraw information from your environment. In this case, your smart building. How are you going to withdraw certain information? How are you going to see, or how are you going to measure how many times a door opened and closed, or what the CO2 levels are, or how if there is any presence in a certain area or whatsoever? How are you going to do that? Where do you need sensors, and what kind of sensors do you need? And then you probably need secondary data. So whereas sensors offer you primary data, you need secondary data from external data sources like the Weather Channel to provide you with an update or an up-to-date weather information. Is it going to rain today? Is the sun going? Like, what is the temperature, etc., etc. And you can use that secondary data to actually make improvements on your building. So once you know what data you need, you can start to extract it. You scrape it, or you take it out of the network, and then you bundle it. You put it all together. It's what big data is all about. Big chunks of data. But because the one data part is not compatible with the other data part, you need to adjust and refine the data in order for you to make assessments out of it. So that's what your data architecture is all about. And once you have a good data architecture, let's compare it to a spreadsheet which is well organized, you can start to make conclusions. And of course, you need an application that is able to visualize all those conclusions and to run all those formulas. And then from that application, this is where I jump back to MyMesh, is how we did it. We have a different take on what smart buildings are. So where most of our competitors or colleagues build single application, we do not build applications. We merely build gateways or a gateway. So we have MyMesh management system. And how does it work? Just like that iPhone, MyMesh management system is a platform for third-party developers to develop on top of our infrastructure. So we have Beveco, we have Mapic, we have Lumitel, which are all applications that run on MyMesh and that show you analytics, that provide you with indoor navigation, that provide you with beaconing or data analytics, all in their own way. And this way, like, the demand from the market meets the supply from the market. Software developers will develop new technology based on what the customer wants. We merely provide an infrastructure for that. So that's how MyMesh differs from any other competitor, is that we do not have one single option for our customers. We merely provide the infrastructure that allows them to install what they need. This is also the end of my presentation. I hope you enjoy it. If you have any questions, don't hesitate. Fill in a comment below and I will get back to you. If you want to see more like these kind of videos where we zoom in on different elements of smart buildings, let me know as well and I will continue. Thank you for watching and hopefully till the next time. Bye bye.